Hey guys, thank you so much for tuning in, Algorithm Associates. I appreciate all of you so much for watching today. And today we are going to be learning how to reverse a linked list both iteratively and recursively. I hope you're as excited as me. What is up, Algorithm Associates? It is Gabriel here, and today I am going to be showing you guys how to reverse a linked list both iteratively and recursively. So, to start off, what is a linked list? A linked list is a data structure that is built of nodes, which just have two attributes. They have a next attribute and a value attribute. So they can have any value in them. In this case, we are going to make these nodes have the values A, B, C, and D. And then finally, we know we've reached the end once we reach the null. So the last item in a singly linked list will point to null, and that's how we will know at the end. So we're going to start with the iterative solution. And in this, we are going to need to have 3 pointers. So we need to have one, which we're going to call P for previous. We're going to need to have one for C, which is the current node. And then we're going to have one for the next node. So we're going to have a N right here. So we have these nodes identified by these pointers. So we make this linked list out of these list nodes. And then we say that P is just equal to null. And then we say that C is equal to the head, where we're starting. And then we just say that N is equal to C dot next. So the one following, which is B. So in the iterative solution, essentially what we are going to do is we are just going to be pointing the current node right here to the previous, and then we are just going to be pushing each of them forward until next is null, and then we will set the current to the previous finally, and we will return with D. So I will just draw this out. So first of all, we start with A, and this is the first step. We are, well, the first step actually is we are going to make sure we're doing a check to make sure the list is neither one node long. In this case, we have nothing to reverse, so we are just going to return it like this. And if there are no nodes, if the list is given to us as just null, we are going to return that as well. But besides that, we are just going to get going. So we are going to start with C, which is A, and we are going to change this pointer to point all the way towards null where we initialize P. So this is going to be the last node, of course, so it'll be similar to how D is right now. So we have that pointer going there, so we lose the pointer towards B, but that is A-okay, because we still have track of the next node in the list within. So we are going to set P equal to C. So we're going to set P equal to C, and then we're going to set C equal to N. So we're going to move the pointer along here, so C equals in, and then we're going to say in equals in dot next. So we're going to move in along one here. So from here, we are going to repeat this again, and we're going to say C equals, or C dot next equals P. We lose this pointer, and we are just going to continue along by moving all of these forward one as we just did, and then we are going to set C to B, and we are going to set D to C, and then we lose this, and this is the list reserved. This is the linked list reversed as D to C to B to A. Not too bad. So this is fine, but it has a few problems. You have to keep track of 3 nodes. You have to constantly, or 3 pointers. You have to constantly move them around. And it takes longer. It's not the fastest way. So if the linked list is small enough, depending on how big you want the stack size, it is better to do this recursively. So I'm going to hop into the code section for the iterative solution first, and then we will hop right into the code section. All right. Alrighty, guys, so we are back, and this time we are going to be doing the solution recursively. So this one can be a little bit hard to follow, so I'm going to see if I can do this sort of slow. So to start, we are going to do the same cases as we did before. So of course we're going to say initially if C, the current node we're on, equals, let's give myself a little more room for when I draw this out. So we're going to say if C is equal to null, or C dot next equals null, in this case, we are just going to return the head, and we will see why this is in a minute. So just bear with me here. So we're just going to define this as the function recurse. So I'll just do the little JavaScript shorthand here. So yeah. So we are going to start by making sure it's not already null, because then we would have nothing to reverse, or the next one isn't null. After that, we are going to set our next, or we'll call it our new head. We're going to set our new head equal to this recurse function. And we're going to pass into this recurse function our head dot next. And initially, this was a little bit confusing to me. But essentially what we're going to be doing is we are going to be saying that we're making, right now, we have our current right here. We'll call it C. We are not doing anything with that yet. Well, actually, head should not be head. It should be C. We'll call it C. C.next. And what we're going to be doing is we're going to be setting this variable, new head. And what we're essentially trying to set this to is we want to set it to the last point. What we want to happen is we want to recurse until we're going to say new head equals all of this. And then we're going to say that new head equals all of this. And then we're going to say that new head equals all of this. And then bam. Once we get to D, it is going to say, okay, C.next is equal to null. C.next is equal to null. And we are going to return head. And by the way, in this recurse function, C is the parameter. So I'm just going to draw this out. We're saying in H equals the function of all of this. And then we say, okay, didn't hit this yet. We're going to recurse again. And then we're going to say it actually equals the f of all of these. And then we're going to say, okay, well, again, dot next is still not null. And then we do it this final time. This time, however, D.next is null, and D is currently C. D is currently our current, so we're going to recurse back through. So, we're going to add the rest of this in a second about what happens here. But at the very end here, we are going to again return head. So once all of these have been fulfilled and they've been returned to, we are going to go back. So we have D, and then we're going to say D equals this, but then it bubbles back up again. D equals this, and then it bubbles back up again. And then we say D equals this, and look, we've returned to our final function. So now we have in H equals D. And to keep this nice and easy, I'm just going to write in H right next to D. So we have the pointer of our new head right by D. So this is great. We have our new head indexed as D is going to be the new start of the string. But during this process, we have to do a couple of things as we bubble back through. So during this, what we are going to be doing is we are going to be setting the current head. So between this, we are going to set C dot next equal, or yes, we're going to be setting C dot next equal to the item before. Let me just look at my solution here to see how I want to write this out, so I want to write it correctly. So where is this at? All right. I'll cut back here. Okay, yes, I'm back. So what we're going to be doing here is we're going to be saying c.next, and I'm going to explain what this means in a minute. c.next equals head, or equals c. So essentially what this is saying, so first of all, we've already completed this last recursion part. We've already returned this. We returned this because next was null. So we're not going to do it for this one, but we come back to this one, and this is currently C, and we are going to be saying c.next, D, c.next's next is going to equal C. So we have D's pointer now pointing to C. And then right after that, we're going to say head dot next equals null. So we're going to say that C's pointer now goes right to null. So we have C's pointer pointing at null now, and D pointing at C, and then we come back through, we return, and we bubble back up. So now we are at B. So we're going to say B.next. So C's pointer is not going to be, unfortunately, at null anymore. It is going to be at B. And then again, we are going to be pointing B towards null. And then we're going to bubble back up one more time. This time, we're going to be saying, again, C is A. C.next equals C. So we're going to be saying this B points to A as A.next is C. From here, we're going to do this the final time, and we aren't in any recursion loops anymore. And we are going to point head.next, so A's pointer, to null this final time. Of course, this isn't here anymore. And just like that, our linked list is reversed. And if we just draw it out one more time, it is now going to look like this. It's going to be D points to C, points to B, points to A, which now, if you look at this, points to null. So that is great, and that is our solution to reversing a linked list recursively. All right. Thank you so much, guys. What is up? Now on to the code portion of the video. Peanut is very exciting. She is vibrating. I think she is just so very excited to learn about linked lists today. Isn't that right, Peanut? Alrighty. So, to start, we are going to do it recursively. And again, to do this, we are going to have 3 pointers. So I just want to see if we can build it like this. No. I'm just going to pull this list node object in right here. So cool. So yeah, this is it. So first of all, to construct this linked list, we are just going to set the head equal to a couple list node objects in each other. And then the value of the first one is just going to be A. And then we're going to have another list node object. And the value here is going to be B. And we're going to have another list node object. We're just going to do 4 of these. C. And then we're going to have one more list node object, which is going to be D. And if you look, it already ends with null by default, or none in Python. So, with this, we are going to start by just writing out a little function to iterate through this. So we're going to say def reverse and we are just going to pass in the head as the only parameter for this. And then we're going to say with the head, this is just to traverse the list, we're going to say head dot next is what we're going to set head equal to. And then we're just going to print head dot val, and I'm going to do this the other way around actually. So now if we run this, you can see right here we get 9. I did the wrong one. It's reverse linked list. Reversing linked list. It's the wrong one. And of course, we never called the reverse function. So that is clearly important. And we get a nice juicy error because we didn't pass in our head. And we get A because it's not recursing. Yeah. So then we're gonna say so yeah, we're gonna say head dot next equals, or head equals head dot next, and then we'll just do it like this for now. And then we're just gonna pass the head back through, and we're gonna live through there unless if we hit null. Yeah, and then we're going to say here, well, we don't need to do this recursively actually, so there's no reason to do this. We're not doing this recursively yet, so we're saying for, or so yeah, we're going to say while head, and then the truthiness of this when it's not equal to null is going to be true. So we can just say while head, I think. And we'll see what this, yes, this works. So we're just going to say while head, then this, and then, yeah, we are doing this now. But if we want to reverse this list, we are going to have a few more pointers. So we are going to say head equals head.next every time, of course, to iterate through that, and we'll do that at the end before we check if it's not null again. But pretty much what we are going to do is we are just going to create those 3 pointers. So we're going to have C, which is current, equal to head. And then we'll put P before it, and we'll say P is equal, initially at least, to null. And we will say that, and this is all going to actually be initialized before the while loop even. So we're going to say that P equals null, C equals head, and N equals head dot next. So great, we have these 3 pointers just as we did in the whiteboard. And now we are going to start the while loop. So what we're going to do essentially is we are going to say while head dot next is not null. So we're just going to say while head dot next, we are going to do all this. We'll drop the print statement for now and just see if we get any errors. And then we are just going to start pointing. So we're going to set C equal to P. And then we are going to set, we're going to set C dot next equal to P. So we're going to point C dot next to P. And then we are going to say we're going to say C, we're moving our pointer from C to N, so we're saying C equals N, P equals C, and then we're going to say that C equals N, P equals C, and then finally we are just going to move N forward. So N equals N dot next. So we do that, we move them all forward, and then we loop again. And let's see where this gets us now. And then, of course, after this, we are just going to return C. But I feel like I'm missing something here. So let's just try this out. We're just going to print reverse.head. And we get a big juicy error. So function object has no attribute next. Okay. So where is this? So actually what we're going to do is we're going to say while in, we're going to do this. And then it says function has no attribute next. Well, that should definitely not be a function. So it says in line 25. Why did I put this? I did not mean to leave that there. But what we actually want to do is we want to print it all out. So we're just going to traverse it again. So we're going to say head equals reverse head. And we're going to mutate that original object. And we are just going to do the nice while head. And then, so while it's not equal to null, we are just going to print head. And then we are going to do a head equals head dot next. Print head dot val. So that's good. The first one is at least. But for some reason, this isn't staying true, even though there is an item there. Let's try just printing head here, and we'll see what we get. I'm guessing an error, and we get none. That should not be the case. It should not be D none. But I think what's happening, so let's just walk through this. So we put this in here, and we have these pointers initialized, and we say while in, we are going to set c.next equal to p, which is null, but why? Why are we setting it to p here? We're going to set c.next equal to c. Nope. Peanut wants to play, but not with my algorithms, Peanut. All right. Okay, so same problem again. And what we want to do is we want to set, c.next equal to p. This is right. But no, we don't want to move it like that. We want to move p to c first. So let's just print c.val as it goes. So B, C, D, D. Okay. So let me just do this again. So what we want to do here is we want to set, that'll do it. So the problem is so I want to set a.next equal to null. So I set c.next to p. And then I want to set p set so then I want to say p equals previous equals current, and then c equals n equals n dot next. So then we reverse head, and then I guess, so what it should be doing here is we set c.next equal to p. So we point A to null. We go through here, we move them all forward, and then we set c.next equal to p. So we set B pointing to A, and then we loop through again, and then we say c.next equals p. So we're going to set C to B, and then we go through again, and everything moves forward, and then we say c.next is equal, and then we say c.next is equal to p. So we set B pointing to C, or we set C pointing to B, and then we say d.next is equal to C. But at that point, it's still not null there, and that's the problem. So a better base case here to break it is while so would it hurt to do this before? Alright, so we're going to do a little paint troubleshooting. So what we're going to do here is we have A, B, C, D, null. So what we do first is, so first of all, P is equal to null, C is equal to A, and N is equal to the following. So all of these pointers are set, and then we say while N. So while this is true. So it starts off, and then I say c.next equals p. So A points to N, and then of course we don't have this pointer anymore. And then we say P equals C. And then we say C equals N. And then we say N equals N dot next. And that is still there. So good stuff. So then we're going to say that C equals P, or C dot next equals P. So B points to A, and this is gone. And then P equals C, C equals N, and N equals this. So we have PCN forward again, so N moves forward one. Okay, so now we're going to say that C dot next equals P, and then we are going to say move them all forward one. So then we're going to say P equals C, C equals N equals N dot next. So ideally here on this operation, we would set C equal to P, we would set C equal to P, and then that would be it. We would just return C, and my linked list would live happily ever after. But for some reason, that is not being the case, and I think I know why. So, what we're going to do here is instead of, so we say C dot next equals P, so we do that, and then we say P equals C, and then we say that C equals N, so then what we're going to do is instead of this, because N should already be there, we are going to say if N, it should be null there, so we return okay. So, well, what I can do actually is I can just make this always true. But then we can say if C equals this is a little better. I'm kind of happy with this. So it is reversed now. Pretty much all we need to do here now is say not equal to none instead, because maybe none doesn't evaluate to All right. Well, great. We reversed the linked list. We did it, and we actually did do it. But for some reason, this while loop is making me angry, or is angry. So here is the code for the iterative solution that probably isn't best practice, but it works. Me traversing the linked list so much, no. Okay. So now we're gonna do the iterative solution. Okay, actually, we need to make this work because I need to print this out after. Head equals head dot next. So the problem is it's hitting none. I don't mind the error actually. It's kind of nice. I like the error. So I thought. Let's try this. It works! I don't know what that last object is, but I honestly don't care. I don't know why it's doing that. It should have been set to none. but it works. Okay, cool. So I'm cool with that. So now time for this nice, delicious, recursive solution. So what we're gonna do here is we are going to say if head equals if head is none, or head dot next is none, we are going to return head. However, we're going to say new head equals head dot equals reverse head dot next. And then from there, we're going to say, once we are done recursing and we retrieve the new head, we are going to say that head dot next equals head as we recurse back through. And then we're going to continue that. And then we are going to say that head dot next is equal to the null pointer is equal to none. And then we're going to say that that's it. We're just going to return new head. And that is ideally it. And yeah, that reverses it recursively. So I don't know why the recursive solution was somehow faster for me to make. But regardless, that's it, guys. It took me 33 minutes to reverse a linked list.